We're going to take a look at a tool called nmap here. Nmap is used for network mapping. We're trying to figure out what's happening on a computer. Like, what is that computer set up to do? Security administrators might use this tool after they configure one of their servers to check to make sure the firewalls are configured correctly. They'll make sure that the correct services are listening on the correct ports, all of that good stuff. If you're an ethical hacker, you might go into an organization. They might give you a blueprint of how the systems are supposed to be set up. You might use this tool to verify that indeed the systems are set up the way that they say they're set up. If you're an unethical hacker, if you're someone trying to break in, you might use this tool as the first step in planning out a subsequent attack. For example, you might use this network mapper to determine that the server is running insecure software and there's an exploit available for that specific software. So you would potentially use that in the second phase of an attack. So it's important, because this tool can be used for good or malicious purposes, to use it with permission. It's not a good idea just to go out and start port scanning people just to see what's going on. You should have permission to scan all of the targets. In this exercise, we are going to scan a target where everybody's been granted permission to scan this particular target. So I'm going to jump down. You can read on your own time. Let's take a look at our IP address. ifconfig is not available on this system. So instead, we're going to use IPA. This will show our IP address 172.31.50.60. It's also available down at the bottom of our screen here. Amazon in its web interface shows that to us. But if you're on a remote server, you might not have Amazon's interface here. So IPA shows it to you. This is one of those cases where some Linux tools are on some systems, but not others. Let's try hostname-i. Let's see if that will work for us. And yeah, so that gives us our IP address as well, just our private IP address. In our case, because we don't have ifconfig eth0 is not going to work for us. Many desktop systems are going to install that ifconfig. Because we're on the server, it's a little bit leaner. They didn't want to install both tools, so IPA works for us. We want to make sure that we have nmap. We did install it previously, but let's say you don't have nmap. How would we install nmap? Sudo apt update. That updates a list of packages. Sudo apt install nmap. I've already got it, so it says 0 upgraded, 0 newly installed, 0 to removed, like everything's fine. But if you had to rebuild your Linux system, you would run those commands to make sure that nmap was installed correctly. So let's do our first scan. nmap, and then we're going to give it the target. So scanme.nmap.org. You can see in the target's name, it says scan me. The creators of nmap built this target just for scan testing. They say, please don't overwhelm them. But we can see we've got a couple of ports open here. So here's the output. So if I am an ethical hacker or a security researcher contracted by the creators of the nmap.org website, I might use this scan to give me a little bit of information about their particular site. So what are they running? Well, they've got port 22 open using TCP. These are all using TCP, the Transmission Control Protocol. It's open. Great. And what's the service running? It's the secure shell. So theoretically, if I've got the right credentials, I could log into that server with a command line interface, similar to how I logged into my Ubuntu machine here. I don't have the right credentials. I'm not going to be able to log in. I see that port 25 is filtered, so it looks like it's blocking me, so I'm not going to be able to connect to the simple mail transfer protocol service to send email on their email server. I do see that port 80 is open for HTTP. So HTTP is used for websites. So I could go, theoretically, I could open up my browser tab and go to their site. Let's not even make that theoretical. Let's just go see. It's like, okay, I've discovered some information from this scan, but this should move me to some kind of action. So I'm going to check out their website. This is not hacking. scanme.nmap.org. So that's the target I scanned, scanme.nmap.org. The scan told me that HTTP was open, not HTTPS, just HTTP. So I'm going to go there. It tells me it's not secure. It's just because it's not encrypted. And we do see that, in fact, yes, what nmap told us was open is indeed correct. They tell us we set up this machine to help folks learn about nmap. A few scans a day is fine, but don't hammer them or try to brute force hack their site. So we're supposed to be cool. So we're going to be cool about this because we're just learning. We're not trying to cause trouble for these people. Port scans can be quite intrusive depending on how much data you throw at the target. So we do want to be careful. Some organizations do monitor and look for these scans, and if they detect that somebody's scanning them, they can block their IP address. If you were doing this on your corporate network internally, you might get a call from your security team saying like, yeah, you're Beth in accounting. You're not supposed to be running port scans. Do you have malware on your machine, or are you just doing this for extra credit? And that extra credit might mean training for violating, corporate security standards, because you shouldn't have this tool on your computer anyway. All right, quick pause. So we did our scan. It told us some information. We see what's open. They've got some weird ports open there, just like to respond, basically. But all that's fine. The IP address that you got back could be different than me because they might move their site, but it looks like it's still consistent for me, so their IP address has not changed. Neither has the IPv6 address from the time I did this previously. We did go to their website because it showed us that it's there. All that's good. We can test this nping. It's just for network testing. Let's see if we've got that nping tool. I'm just going to try to run nping. Let's see, is it on this system? Nping scan me. It is on there because it ran. Nping scan me.nmap.org. And I'm going to say -p for the port. And nmap told me it was running on 9929. Okay, that's good. It worked. So we were able to use the right tool to connect to that specific port. We used our web browser to connect to HTTP. We used the nping tool to connect to, I'm scrolling up a lot, I know, it makes people dizzy, to this nping echo service that they're listening on. And Elite, they're just kind of trolling us there. Okay, so what if we want to dig a little bit deeper? So we can run other scans, like we can say -a. This is going to do quite a bit more for us. nmap-a scan me.nmap.org. This is going to be more thorough. Not only is it going to try to detect what services are running on the server, but it's also going to try to tell me the software version that they're actually running. Because just because a remote server is running SSH tells me it can try to log in, but it doesn't necessarily tell me if that version is vulnerable to something. Okay, so when I do -a, I look at the output. Now it tells me, yeah, port 22 is listening for SSH, and it tells me it's running OpenSSH 6.6.1p1 on Ubuntu Linux. So I'm learning a little bit more. I can see that the website is open. I can see the web server that it's running. It's running the Apache software, which is good software. It says, go ahead and scan me. It even tells us it's running the operating system. It's running Linux, but doesn't give us a lot of detail about that. So this scan is a little bit more intense, takes longer to run, and it creates a little bit more network traffic, so it's a little bit more intrusive. So we do want to be careful. That's why we're doing it with permission. What else can we do with nmap? There's tons of stuff. If you're in cybersecurity, nmap is one of the tools that you just have to be at least somewhat familiar with. Nmap, I'm going to run the manual for nmap, nmap, and let's take a look. The documentation is rich. There's lots of stuff. If you want to send your packets faster, you can use T4. So take a look at the manual. Let's see what we can find. Gosh, there's so much information here. I know it's really dense, and you look at this and like protocols, Christmas tree scan, like what the heck? There's lots of tools. Like if a hacker is thwarted trying to use nmap to scan a target, they might be judicious and try some of these other options to try to like get past the firewall, for example. Lots of good stuff there's that we're not going to go into right now. One thing I'll take a look at is OS detection. The -O enables OS detection. That's okay. We already saw it because like -A is going to do that also. -A includes capital O, but hey, let's do it anyway. nmap-big O scanme.nmap.org. And notice it says it requires root privileges. So how do we give ourselves root privileges? Let's run sudo nmap scanme.nmap.org. What this is doing, it's sending packets and looking for the way that different versions of Linux might respond. And it's not an exact science. Like Linux isn't going to come back and say, this is my specific version. It's got some guesses for us with confidence levels. It's got a high percentage for a few different ones. Looks like it's running a little bit older version of Linux, most likely. Typically, it's not going to come back with an exact version, but we know it's running Linux, so that can be helpful. We learned that from figuring out that they were running the OpenSSH version for Linux specifically anyway, but that's fine. So lots of different things that you can do. You can look in the manual, see if you can read what these different things do. Take some time to explore the manual, learn how to read the manual, do some testing. You can scan yourself, or you can scan your Windows system. Let's see, I shut my Windows system down. But if I wanted to nmap 172.31.50.50, I could try to run it to save money, because I'm cheap. The host is down. You can boot up your Windows server. You know what I'm going to do? I'm going to pause the video right now, boot up my Windows server. Okay, so it took a couple minutes, but I booted up my Windows instance so I can check. Can I ping it? Ping 172.31.50.50. That's the private IP address of my Windows server. Yeah, it's up, and look at that response time, less like half a millisecond. That's fast. That's real fast. That's good. So Control-C to stop that ping. So now if I do nmap-a 172.16.31.50.50, let's do a scan. Let's see, did I have a typo in there? 172. What do I do? nmap-a. It's blocking ping probes potentially. Host seems down, so I'm not going to try -A. Let's just try a regular nmap scan. The firewall could be blocking something in there. All right. Host seems down. It's not down, I promise you. So let's try pn. Let's do that. -pn. Go check the manual, see what that does. What does pn do? Okay, so I mean, that worked. So we have to be a little bit creative. Sometimes using nmap doesn't always work the way we think it should, so we do have to be responsive. And this is not abnormal. This is what it is. Notice it says port 3389 is open. That's the remote desktop. That's what allows us to connect via the graphical user interface to log with administrator and our super secret password. So yeah, that's expected. We didn't open up any other ports in the security group when we set up our security group in the Amazon cloud. So there's no other ports open. We did allow pings, but pings don't use ports the way that other services do. So I would not expect to see ping in this list here. So yeah, this is what I expected to see. We just had to add that pn option there. So if you want to go ahead, try different scans. Look in the manual, see what these scans actually do. Requires root. Let's do it. Sudo. All right, interesting stuff. Let's try that -O. Operating system detection. We have to do sudo again. Let's see what nmap does for us here. We might have to scan our target multiple times. This is not unusual. If we were trying to go under the radar, though, doing multiple scans increases the likelihood that someone's going to catch us. Now, of course, we're not trying to do anything malicious, and we should be doing this with permission. I'm doing this on my Windows server, so I'm giving myself permission to do this. But even if you're an ethical hacker, you still don't want to get caught, because if you get caught, it means that you kind of failed in that way. So even if you've signed a contract where they tell you, yes, you can scan our system, you still don't want to be noisy, clumsy, because you want to see if you can go under the radar. So this nmap scan, we know it's Windows, but nmap couldn't find an exact match. That's fine. It's an inexact science. We could try other scans. You can try digging deeper, be creative, be resourceful, use the manual, use Google, see what different kind of scans you can do from your Ubuntu Linux server to your Windows server just to do some reconnaissance about that server. So nmap is good. You have to be responsible using it. Scan targets with permission only. Practice using different options. Read the manual. Use Google. There's probably at least 1,000 tutorials online for using nmap. Lots of good resources are out there.